Very good to be here again in New York, and I'm kind of surprised so many people showed up for a telecom talk. I expected like 3 people, all of whom would be my friends. So as you know, I've been writing for 2600 for quite some time, and telecom's my hobby. There are actually people that know quite a bit more than me, and so I do draw on their work when I write the Telecom Informer. But you know, I've been doing it a while and seen development over a relatively long period of time, and that's something that I think gives me a perspective, being in the technology industry and having followed telecom, where I can see some patterns that are repeating. And so that's what I'd like to talk to you guys about today, and maybe share some ideas for how the phone system can evolve from where we are today. So I first of all just kind of wanted to give a retrospective of hope. We've been here a really long time, coming together every 2 years. And every 2 years, there's evolution that happens around telecommunications. We've been, examining these issues at Hope for probably longer than anyone in the conference circuit. And there's something that I wanted to address this year because it's really come up a lot on Twitter and some of the other forums that I follow, and that's the political nature of Hope. We are unabashedly political here, and particularly when it comes to telecom. If you look at the telecom talks, there is a lot of public policy in them. And if you review past talks at Hope, that's been the case going back for, over a decade now. Why is that? The reason is that it's very difficult to separate the technology itself from how we use it as humans, and how we organize ourselves as humans is generally through our governments. So when we talk about Hope being political, I think that it's just really difficult a lot of the time to separate the technology from, the users. So please do have an open mind, when it comes to politics and technology. It's, with telecom, I'll kind of demonstrate in this talk why public policy is so important and how much of a cornerstone that is in how we all communicate today. So what's the story of telecommunications? It's fragmentation and unity. And what do I mean by that? At the dawn of the telecommunications era, there was no universal phone system. There was no ability for one person in one town to call somebody else in a different town. And none of that happened by accident. That was all deliberate. So as fragmentation became unity, we're now starting to see fragmentation again, and I'll get to that toward the end of the talk. But I just want to set this theme up front, that in telecom, there's a lot of history that's repeating itself. We've had a story of fragmentation at the beginning. We had unity kind of in the middle of the telecommunications era, and now we're back to fragmentation again. Will we get to unity again? It's hard to say. There are proposals to do that. The last speaker had some things to say in that space. I don't know what the answer is, because a lot of that comes down again to politics and public policy and what we decide as a society we're going to do with telecom. So this is a timeline about the early days of telecom, and I kind of want to set the stage by just grounding us all with a common set of knowledge around the pace of innovation. And what does that mean? Usually when there's a new technology, you see a lot of rapid iteration around that technology, right? There's, when we started to have internet access in the AOL era, there were all sorts of applications that people built on top of that. And then over time, things become relatively stagnant. If you look at the state of the internet today and what you can do with it, it isn't fundamentally a whole lot different than it was 5 years ago when you look at the types of applications that we're using and the things that we're doing on it. Certainly some of the things that are happening on the internet, like our last presidential election, that's new. The way that people are using networks is new, but the technology hasn't really changed an awful lot in the last 5 years. We have faster connections sometimes. We have new and more creative ways to bill for the same thing. But we don't really, have a whole lot of just fundamentally new stuff. Like the latest iPhone isn't a whole lot different than the previous one. But in the early days of the internet, in the early days of telecom, there was a really rapid pace of innovation. And take a look at this timeline. In 1876, that's when the telephone was invented, right? Fast forward to, the 1880s, which is less than 10 years later, and we have long distance calls. So not only is the whole phone system set up so that you can actually call through an exchange rather than having hard lines between two places, and you have a phone number which people can reach you on versus a name, but you can call people in another town. That's just leaps and bounds above the telephone being invented a few years before, right? 1891, maybe 10 years later, automated switches, so you don't have operators plugging cord boards anymore. You actually have a very rudimentary automated mechanical-based switch being able to make those connections for you. And 1900, of course, all of us here at a 2600 conference are going to have a soft spot for payphones, and that's when the first one was invented. But by 1907, the CEO of AT&T is talking about the concept of universal service. One policy, one system, universal service. So, rewinding a little bit, I want to talk a bit more about the fragmented infrastructure because it's very difficult for us today to even imagine that, except it isn't. Because how many people, and I won't be able to see you when you raise your hands, use messaging apps like Signal or Kik or Snapchat or something like that? What I'm guessing is that pretty much everybody in the room raised their hand, and there's a commonality, a common thread with these apps. If you're in one of them, you can't communicate with people in a different app. Well, it was exactly the same at the time of the early telephone system. If you had a phone from Bell, from AT&T, you actually weren't able to call somebody with a phone from an independent phone company. And there could be 2, 3, sometimes 4 or more phone companies per city. New York had quite a few. All these companies were incompatible with the other ones. So what businesses would do is they'd subscribe to multiple phones from different companies so all of the potential customers who had different phone companies could call them. By 1912, rural exchanges began to be a thing. And so these farmer cooperatives would, go string some line and put in a switch, and, there wouldn't be anybody to really take care of it. And they wouldn't be connected to anybody else necessarily, but you'd be able to call from one farm to another down the road. And so, that met the needs of the local communities. By 1927, there were 6,000 of these things, and a lot of them were falling into disrepair. There just wasn't enough money coming in from subscriptions to maintain the network. They weren't always interconnected, and that was also another really big problem. So around 1907, Bell's customers, AT&T's customers, started complaining that, it was a little bit ridiculous that they couldn't call people who had a different phone company. And this began to be a competitive issue for AT&T, which by then was by far the dominant player in telecom. And so Theodore Vail, this guy was like one of the, early 1900s industrial greats, right? He was into mergers and acquisitions. And so what he started doing is got a whole bunch of money together by partnering with JP Morgan and started buying up every independent phone company that they could get their hands on. And then they also bought the Western Union Telegraph Company, which consolidated a massive amount of power, market power, inside of one company. So, this actually was the first step toward AT&T becoming a monopoly, right? And they were a fully vertically integrated monopoly. They had Western Electric, which was the manufacturer of telephone switches and telephone equipment. 1907, I actually have a typo on the slide. They acquired Western Union, which was the primary method of of long-distance communication at the time was telegraph, so they bought the Western Union Telegraph Company. 1908 to 1913, as I mentioned, they just went on a buying spree and they acquired, dozens and dozens and dozens of independent phone companies. And then, finally, this thing became pretty much a monopoly. So along came the Wilson administration's trust busters. So there was a problem, actually, in the early 1900s. It wasn't just telecom that was a consolidated industry. Railroads were also a consolidated industry with a lot of market power and very few players. And the Wilson administration was very active in filing antitrust actions. So what's an antitrust action? This actually happened against a company I used to work for, Microsoft. The government will declare your company a monopoly, and when they do that, they will seek to break it up or require you to spin out some assets, in order to foster competition in the industry. So how did it work out for Microsoft? They were able to pretty much keep everything that they were doing, but operate under a consent decree by opening up the Office file formats so anybody could work in it. So people that follow antitrust kind of saw Microsoft as the winner there. This was also the case with AT&T. The trust busters came in, and their initial goal was to break up AT&T and require some degree of competition. What that turned into by 1913 was what we called the Kingsbury Commitment, and it's named after a vice president at AT&T who negotiated this with the government. So what happened was AT&T committed to interconnect with other carriers, and they agreed to do that by 1913. However, they weren't really giving up much because that's what their customers wanted. They'd had demand for this for a long time. In 1907, they'd come up with the idea of universal service, and of course what they meant by that was not necessarily interconnecting with other carriers. Maybe the idea that they had in mind more was to just buy them. But the net result is the same. The idea of one system, universality, being able to call from one phone to another phone and being able to do that everywhere. This is something that AT&T agreed to do in the Kingsbury Commitment. They also agreed to spin off Western Union. However, by then, Western Union was a lot less popular. Telegraphs are kind of a slow method of communicating. The cost of long-distance calling had come down a lot. So people were tending to pick up the phone and make a call instead of sending a telegram. So this really didn't hurt AT&T much either. So how do I see this? I see that as a win for AT&T. 1818 to 1819, I think, is a really interesting historical footnote. So this was the first time that the government acknowledged that AT&T was a monopoly and that they had a huge amount of power over American communications. Because in World War I, they nationalized AT&T. They took the whole company over for a year. They were concerned about the security of the communications infrastructure. So the Army just went in and ran the company for a year. The government actually paid AT&T a 10% rate of return, as compensation for doing this. But it was the first formal recognition of AT&T's monopoly over communications in the United States. So fast forward a couple of years to the Communications Act of 1934. The Communications Act of 1934, this is a law that actually codified AT&T effectively as a monopoly. Now, if you're Googling furiously in the background and finding policy papers from the Cato Institute and other conservative writers, there is on the right side of the political equation some disagreement over whether the Communications Act of 1934 really guaranteed universal service and whether it really codified AT&T as a monopoly. What I look at is what the FCC says about itself. If you look at their history page, in the FCC's view, this act gave them the power over AT&T to regulate it as a monopoly, and also gave them the power to require universal service. So what did the Communications Act of 1934 do? It created the FCC, who we all know and love, maybe. It made phone companies subject to FCC regulation, and that's a really huge move, right? So when you create a federal agency and you put an industry underneath the thumb of that federal agency as a regulated industry, then it gives that agency a heck of a lot of power. How that agency interprets the law, the rules that it publishes, are basically your rules of the road as a company and how you're going to be able to operate. So this was a very dramatic change from how AT&T had operated before. They had direct federal regulation. They had to follow what the FCC said. It effectively designated phone companies as common carriers. And what's a common carrier? It means, a railroad is a common carrier when they take boxes from pretty much anybody and move them and have nothing to do with what's in the boxes. AT&T is a common carrier because they don't have anything to do with the content of the communications. They just actually carry the communications. And regulating a business as a common carrier comes with very specific requirements that you need to meet for the government. So for example, if you're a railroad and you're carrying boxes that are full of something the government believes to be illegal, the government has the right to get a warrant and search those. And it's the same that became true with the phone system. Until 1934, there was no federal wiretap statute. One of the first things, and I think this is really funny, one of the very first things that the government did when they regulated telecom was give themselves the ability to spy on it and also give themselves the ability to regulate how spying would happen and how access was granted to the network. The first federal universal service law, what is that? Well, what's the concept of universal service is the idea that telecommunications, like electricity and running water, are basic services that are offered in the United States. We do have some disagreement today over whether universal service, when it comes to water, is a thing we should have. If you look at Flint, Michigan, that is not something that is available everywhere safely. Electricity, the Rural Electrification Act provided universal service in electricity, and the idea being that there are cross subsidies. So even if it's incredibly unprofitable to have telecommunications or electric service in a particular jurisdiction, like on the farm my dad grew up on, still that service would be provided because that's just a basic thing that we do in the United States. And it began to set up the first infrastructure for funding through cross subsidies. And that's a really important point. The idea that no matter where you are in the United States, you would be able to have a telephone. And if you were in, Stehekin, Washington, which is all the way at the very top of, Lake Chelan, you can only get there on a boat and usually not every day during the winter. You'd have access to the same quality of phone service as if you were in Seattle or here in New York. So 1934 to 1996 set into motion a very closely regulated era of telecommunications, and many of us grew up in this era, where if you wanted a phone, you got it from Bell. And if you wanted telephone service, it would be very consistent anywhere that you were. And the pricing was regulated by states, so through what's published called a tariff. And these things still exist in many states because actually a lot of rates and regulations for landline telephone service still carry with them the same regulations as during the regulated era before 1996. And I'll get to 1996 and what happened then later. But during this regulated era, the FCC categorized AT&T as a natural monopoly. And what does that mean? It meant that the government viewed telecom as something that it didn't make any sense to have a lot of competition in. Just like they viewed electricity as something that didn't make a whole lot of sense to have competition in. And so what that meant is that the pace of innovation slowed way down because AT&T didn't really have to do a whole lot more than maintain their current networks at the current level in order to be able to collect a reliable dividend for their investors, right? A reliable rate of return for their investors. So when you're a monopoly, the government sets what your prices can be. They guarantee you a particular profit. But also you don't have to do much to deliver new services. That's all a very slow regulated process. So along with AT&T being categorized as a natural monopoly, the Rural Electrification Act came along. So why are we talking about something about bringing electricity to farms when we're talking about AT&T? It's because that same framework that was set up to bringing electricity to everywhere in the United States is the framework that was used for telecom across this era to guarantee universal service to telecommunication services. The Rural Electrification Act first started with the electricity. It was later amended to telecom. And so the same access to low-interest loans were available to farmer cooperatives, for example, to upgrade their rotting infrastructure from the early 1900s to more modern phone systems, much of which happened in the 1960s and 70s. Telecom pricing and quality were both regulated at a federal and state level, mostly at a state level. But using model legislation, generally speaking, there wasn't a huge amount of difference in pricing and quality across states because what was being done was some tweaking and pulling of knobs and levers to be able to reach a guaranteed rate of return that AT&T was allowed to make and other phone companies were allowed to make. So there's only so many tweaks that you can make to a telecommunications billing landscape in order to guarantee a consistent 10% of rate of return, for example. And there was a really slow pace of innovation, or relatively, I would say. So yes, SS7 came along. We did get digital switching. We got touch tone. We got E911. We even got direct dialed long distance. But when you compare to the timeline that I showed earlier of how rapidly things happened in the first 20 years of telecommunications and the deployment of new telecommunications systems, we're looking at a really long stretch, 1934 to 1996, 60 years roughly, and not a whole lot happened. It was just a slow, steady business. So this is Bill Clinton and Al Gore, and Bill Clinton signed this legislation with a digital pen. It's the Telecommunications Act of 1996, and this is the bane of the previous speaker's existence. He does not like this and the implementation thereof. It was the first major overhaul of telecom laws since 1934. And so the idea behind the Telecommunications Act of 1996 was what we were going to do is shake up telecom, move it from this slow, innovating, stodgy, boring industry, which was really kind of behind the curve relative to other countries and the development of the internet. And we were going to make it competitive and exciting and dynamic and fast-moving. And we were going to do all of this with one gargantuan piece of legislation that was maybe ahead of the technology it was regulating. So what it did was it opened the phone system to competition. And by doing this, it required incumbent providers like the Baby Bells to open up to interconnect and sell wholesale services to competitive local exchange carriers. So this is where your bandwidth.coms came into play. They were able to lease space inside, for example, a US West central office, later Quest, later CenturyLink. And they were able to provide some of their own services themselves. They were able to buy some services and private label them from the incumbent local exchange carrier. And just the tariffs for this were crazy. I mean, there was tariff writers had a field day with this. It was work as far as you could see, being able to get the regulatory infrastructure in place to be able to do this. It formalized a system of access charges. I've written a lot about this in 2600, how there's some arbitrage around access charges. And what an access charge is it's money that a local exchange carrier gets from long-distance carriers to complete a call on their network. And that's how you get things like freeconferencecall.com and other things that are set up in these high access charge jurisdictions in order to stimulate a lot of inbound traffic. There's number portability, so you had the ability to take your phone number and move it to another carrier. There wasn't actually, really a good way to do it at the time, but, the law said that phone companies had to. There was voice over IP carrier interconnection that was explicitly allowed, and this caused a whole lot of problems later. So in my view, in 1996, the digital pen was exciting, but we went from years of a very closely regulated, very closed network to opening up the whole thing practically overnight, and not all of the details were really thought through. So it may be odd for me to be saying this, right? But what the government does has consequences. That's why hope is political, because it can impact technology, and it can happen both ways, right? We can get ahead of how we decide as a society to regulate things. We're trying to figure out now, what do we do with social networks and the fact that they can influence elections and have foreign influence in them. But the government can go the opposite direction. They can completely change laws and force technological change or allow technological change that hasn't really been thought through. So remember SS7, I talked about that a bit, and I teased this in the run-up to this talk. Well, SS7 is a protocol that came about not because the phone company wanted to give you call waiting and touch-tone dialing. They would have been completely happy to earn their 10% rate of return consistently without doing that. What was threatened was actually that their guaranteed profits wouldn't be there, because nothing strikes fear into the heart of a phone company like a threat to billing. And that picture there is a threat to billing. It's a blue box. And blue boxes came along. They were a way to exploit telecommunications infrastructure to make long-distance calls for free. And we don't even think of it costing anything to communicate with anyone anywhere in the world today. But at the time, it was really expensive. If you wanted to call somebody in the United Kingdom, it cost more than $1 a minute to do it. So that's why this box existed. That's actually what 2600 is named after, is the tone that seized a trunk coming out of a blue box. A little piece of trivia that some of you may or may not know. And this was a massive threat to billing. The phone company had to do something to stop blue boxing because it was threatening their profits. The 10% rate of return, and it was generally 10%, wasn't guaranteed. That was just the most they were allowed to earn. But, long-distance calls were a big part of that. So in SS7, this is a network that was developed in 1975 for computers that were contemporary in 1975. And we have a very different attitude today of what constitutes secure. Well, in 1975, if you were on the network that ran the phone system, you were inside a secure facility. Usually you had to go through 2 locked doors. Some places there was a guard there. This network was one that you just weren't on unless you were inside of a phone company physically. And what they needed to design this for was 2 things. The first was to be able to accurately do billing outside of the voice band that people with blue boxes had access to. So it had to be a separate network, it had to run in sideband, and it had to operate very quickly. There are some other features that the phone companies thought they could sell, and things like caller ID and voicemail and call waiting. And SS7 enabled these, but in 1975, the computers that ran phone switches weren't very powerful. So the idea of having authentication and encryption wasn't something that they could do with the performance that computing at the time allowed. SS7 is unauthenticated, it's unencrypted, it trusts everything, and so it's the equivalent of if somebody shows up with a bogus contract from Nigeria, having to not only honor whatever access they want to your network, but also allow them to claim that they're a bank. And that's the phone system today. That's SS7. And that has led to robocalls. This is one robocalling company's ad. And there's how do robocalls work? Well, what I can do if I want to robocall people is subscribe to a voice over IP dialer platform. What those dialer platforms do is they will spoof whatever number you want to claim to come from, or however many hundreds of numbers you claim that you want to come from on the SS7 network. How do they do that? It's because SS7 is trust by default, and these shady phone companies have direct access to that network. So they can claim to be pretty much whoever they want to be. And it's very, very cheap using these tools because, being phone companies, they interconnect with other ones at very low rates. So this is kind of the crux of the robocall problem. The biggest problem with robocalls is not the fact that they're happening, it's the fact that they're really cheap, and it's the fact that it's impossible to know who's actually calling you. And I'll talk a little bit about the economics of robocalls here, because I think that they'll be really shocking to most people. So if you want to, get into a campaign robocalling people, you can call everyone in Seattle, every single person, literally all of them, in around 28 minutes for around $150. And that's using a mid-sized dialer platform. There are bigger ones. So the barrier to entry is very low. The cost is almost nothing. And that's the economics that we're up against with the problem that opening up access to SS7 has created. So phone companies are aware that this is a problem, but keep in mind what motivates phone companies. Billing. That's the number one motivator. So phone companies don't really care so much that robocalls are happening. What they do care for is that they can't bill for them. And so when you look at the design of the shaken and stir architecture, this is something that really is being driven by billing. So, it's conveniently also a way for larger phone companies to lock out smaller ones, because by putting together a very heavy authentication infrastructure where you have to buy certificates in order to authenticate calls between phone companies, and there are, this particular proposal has an unnamed set of large phone companies that are actually going to have signing authority for smaller ones. So if you're a smaller phone company, you'll have to go through a bigger phone company and pay them to get access to the network. This really isn't something that I think will stop robocalls on its own. What is it? It is an interesting way to secure SIP. So right now, most calls between carriers are already settled via SIP, but SS7 has to be supported because many older phone systems don't support SIP. What's SIP? It's a protocol to deliver voice over IP. So this creates a certificate infrastructure for SIP that basically supersedes the unauthenticated one today, and that allows phone companies to authenticate themselves with other phone companies. It's similar to X509 or any other kind of certificate infrastructure that you look at. Who's the certificate authority? Well, that's still to be worked out. Neustar really wants to be. They're kind of looking for a reason to exist right now. But who will that turn out to be? It's going to be one certificate authority, and that will just be a license to print money for whoever it is. And how's it going to be limited? Just to North America, actually. So the utility, again, is limited because the phone system is global. Why don't I think this is going to stop robocalls? Phone companies make money from robocalls. Let me say that again. Phone companies make money from robocalls. Why would they stop something that's making the money? What they actually care about is being able to correctly bill for robocalls. And that's kind of a problem right now because many of the shady phone companies that are allowing spoofing also are spoofing where they themselves are coming from. They're leaving certain SS7 fields blank that tell phone companies where to bill those calls back to. And so, phone companies make money charging you minutes to deliver the calls, but they don't make money from the phone company that sent the traffic, and they also want to make that. So this is what Shaken and Stir will really fix, but I don't see that they'll be motivated to stop robocalls themselves. There's no strategy to stop robocalls from international numbers today. So instead of getting, calls from the first three digits, the area code and first three digits of your number and some random 4, you might start seeing calls from China. There's no strategy to stop robocalls from domestic numbers that aren't spoofed. So as long as I'm willing to pay, $1.35 to set up a real phone number, I can robocall you all day under shaken and stirred. It doesn't stop me from doing that. All it will do is properly authenticate what phone company and number I'm coming from. And even if phone companies wanted to stop robocalls, the technology is so good to do robocalls these days, the platforms are so large, they can push so many calls that it's really ahead of phone companies' ability to counteract it, at least today. And also, keep in mind that the Telecommunications Act of 1996 didn't change anything from 1934. Phone companies are required to deliver all traffic. So unless phone companies get the legal authority to stop delivering traffic that they suspect might be a robocall, it's not going to move the needle at all. And in all fairness, the FCC did rule that if you are calling from a number that is disconnected, or if you're claiming to call from a number that's disconnected, or if you are claiming to call from a public safety answering point, a PSAP, so this is like a 911 back number, phone companies are now allowed to block that traffic if they can reliably detect it. But, it could go farther. I'm just not sure how much farther. We'd need more than shaken and stir to do that. So what's our path forward? I alluded to this at the beginning of the talk. Well, maybe we just go back to fragmentation, like at the very beginning of the phone system. Like these are just a few of the messaging app logos that I was able to find when I was Google searching images yesterday. There are many, many, many more, right? And so we could all install 15 different messaging apps and try to juggle calls between them. That's a possibility. But I don't think that that's necessarily the best possibility. I think that that's something that we're doing today in order to adapt to this world that we're in, where, when your phone rings, you can't really assume that it's anybody that you know, even if the number is someone that you know. So I'd like to follow a different path. I think that the world's oldest and largest social network is worth saving, and that's what the phone system is. It's the world's oldest and largest social network. It has the most reach. And, by combining the phone system, which is the world's oldest and largest social network, with a very large social graph, and doing sideband authentication, I think that could actually work. And so how would that work? What you would do is, if you have a cell phone with the, for example, Facebook Messenger client installed, you'd authenticate your outbound call with Facebook. When somebody receives that call, the Messenger client will check to see whether or not the call was authenticated. And if it was, you'd get a blue check mark or whatever Facebook decides to do. Why Facebook? I'm not sure I trust Facebook any more than I can throw them, but they have the largest social network in the world pretty much. And not only that, they have everybody's phone book because they tricked you into giving it to them. So they have the ability to do this. They certainly have the data to do this. I think that the devil you know is maybe better than the devil you don't, and it's always possible to regulate this later on. It has happened in history. It could happen again. So I think that giving Facebook that power is actually on balance less bad than the status quo. I pitched them, I pitched Google, neither of them hired me to do this, so I don't think this is actually going to go anywhere with either company, but I still think it's a really good solution. So at Tour Camp, I was hanging out with ThoughtFreaker, who is one of the few freaks that I know who knows more than me about telecom, and he knows a lot more than me about telecom. He's a really smart guy. He runs the switch for ShadyTel, if you've ever seen ShadyTel, like the, yeah, awesome, I love ShadyTel.
Get your facts in a hot tub.
So, one thing can happen when you get two freaks together and a bottle of very good scotch, and thank you to the random guy from Scotland who showed up with all the scotches at Tour Camp, because that's what caused this to happen. It turns into a very drunk technical conversation. And so we had a drunk technical conversation, and a couple of associations that other people haven't made, we've come up with. So what that is why don't we just score calls as they come in using data that already exists and is accessible through existing telecommunications infrastructure? And what are those things? LNP data. Has the number been ported recently? CNAM, does that data exist? Is there, does it look sketchy? LERG data, is the number even routable? Is this something that's, that's a valid path to get there? Even SS7 messages related to whether or not the call can be completed. So we walked through basically every field in SS7 to figure out what we could use to try to detect whether or not something's a robocall. We have something that we think will stop around 95%, and we're actually prototyping it now. It's a research project. I'm not announcing a product. We're way, way, way off from that. We don't even know if this thing works, but we think it will work, and that's why we're prototyping it. We're looking for collaborators. I need a back-end developer, web developer, to integrate a couple of APIs that we need access to. So if you're interested, I'd love to talk to you. To do this for real, to get to 100% or close to that detection, we'd actually need to be a phone company, and that costs around $1 million. So if you're very rich in the audience and you want to start a phone company, come talk to me after the talk. We might be able to work together. So with that, that's the past and the present and the potential future of the phone system. I've kind of focused in on, the biggest problem that we all have, which is robocalls. Happy to talk about other topics, address other topics. If I don't know something, I'll tell you. I will ask, one thing that happens a lot is that, because we're very political at Hope, sometimes we see a question mic as a soapbox. I don't get to all the questions if we soapbox here. So I do encourage you next time, do submit a talk if you want a soapbox. But if you have a question, I'd love to answer it. And thanks very much.
Question, a bit off topic of this, but could you give us a 1-minute explanation of why we can't trust SMS as a two-factor authenticator, for instance?
Oh, sure. So SMS travels over the same networks that are vulnerable to robocalls, and so you can spoof those too.
So sometimes when robocalls come in, the caller ID name field will say spam, question mark. Who's putting that data in there? Is it the telephone company that's recognizing it as a robocall and marking it spam, or is it an honest robocaller so that you can filter it?
No, what that is you have T-Mobile, right? Yes, no, maybe?
Do you have T-Mobile? Because that was my question too.
Like a Verizon.
Oh, you have Verizon. Okay, so they're implementing this too. So there's a company in Seattle that works with T-Mobile, because T-Mobile's based in the Seattle area, and they're starting to work with other phone companies. What they do is they look at some of the same kinds of metadata that we're looking at, but what they're looking at themselves is, has the same number called thousands of people in the last 10 minutes? And if it has, what they'll do is throw a flag. And actually, phone companies aren't regulated in what they have to deliver as caller ID data, which is why they're able to substitute, spam likely.
Cool. That was going to be my question as a T-Mobile user, but that makes me think also I have a Google Voice number, and I get basically zero spam or anything on that. Do you know what they happen to be doing to be so good at it?
Google is really good at filtering spam. That's why Gmail is so popular. Facebook actually is also really good at filtering spam. They are amazing at that. That's why I think they are by far the best social graph to use with this. It's just going to be really hard to get past their, the stuff that they've developed for 15 years, stopping automated account creation and spam inside their network. So how does that technology work? My understanding of how the Google Voice product operates is that they've taken some of that secret sauce from Gmail and applied it to phone spam as well.
Right on.
Fantastic talk, thank you. You really opened my eyes to one thing that really kind of amazed me, and that is the number of calls that could be made. When you had that slide about Seattle, that was very impressive. But I'm waiting for the other shoe to drop where you mentioned how profitable it was. So do you have any information about these spam callers, how much money they actually make to keep them doing this? It seems like a lot of people don't take the bait.
You know, it's the same as sending email spam, right? You don't need a whole lot of responses because it's so cheap to do. If you can call all of Seattle for $150, how much do you need to scam somebody for to be able to make that up and then some? And how much money do you need to make if you're a scammer in India where you can comfortably live on $500 a month? I've got 2 minutes, so let's keep the next questions quick.
Okay, I'm a terrible person. I have a CenturyLink T1 line. I used Robocalls Seattle. So there's a billing number field and a caller ID field, and they let me spoof the caller ID field and not the billing field. When they add this authentication, why would they change that? Why would they stop me from spoofing the caller ID field?
So under shaken and stir, it's really going to be up to the carrier that you're authenticating with to assert that whatever you are claiming you're doing is legit. And so actually, yeah, like if CenturyLink wants to let you spoof and they're willing to sign off on that, it's totally going to still work.
It sounds like there are a lot of parallels between SS7 and BGP, right? And that you just like say, this is who I am, and the network inherently trusts you. But the way network operators have sort of fixed this with BGP is they get together and they're like, this particular network has been a jackass for a while now. Let's just stop trusting them, right? Let's like kick them off the internet.
Yeah, you can't do that with telecom because it's illegal.
Oh, right.
It's like, first of all, even meeting together is collusion. And then the next problem is like the law says you have to deliver calls. So yeah, you can't do that. Like the internet is not regulated the same way. You can totally get away with stuff you can't with phones.
About a year and a half ago, all of the spam calls I was getting switched from being area codes I didn't know to being my own area code. And I was wondering if that was a result of a change in the system, or as I've heard from people I don't necessarily trust to be correct on the subject, that there was a problem with a local exchange that leaked a bunch of information.
No, there's 2 reasons why that's happening, I think. The first is people are more likely to pick up a call that looks like it's local. And the second is there have been some changes in the way telecom billing happens, and this gets really wonky and long, and we don't have the time. I've got 2 more minutes, I think. So I had 2 more minutes. So basically, you can get away with billing shenanigans more easily using local numbers versus ones that are remote.
If SS7 is in place to deal with billing issues and you have to collect all this potentially fraudulent information to ex post assign costs to people, has the industry ever considered tokenizing payments over like the Lightning Network that runs on top of Bitcoin, that basically you front the money ex ante before you attempt to say, hey, run this data over your network, I will pay you for it. Here's a cryptographically secure
I totally want to wait 13 minutes for all of my calls to go through. No.
But if you're using the Lightning Network, you don't need if you use the Lightning Network, you don't need to wait on a block. It's instantaneously, you essentially.
Yeah, no, go pitch blockchain to somebody else. I don't care.
I think it has application.
I don't mean to be a jerk. I think we're gonna end there. It's the blockchain part of the question. All right, thanks, guys.